Hello everyone, myself Indranil Mondal. Today I am going to deliver another important topic on materials engineering is mechanical properties of materials. Let's discuss. Advances in computer technology have made design engineering quite sophisticated. Mathematical models are used to study stress and process kinetics. Computers can make detailed drawings, and machines are often controlled by mini computers. Even with these engineering aids, the basic machine design is intuitive. When a design engineer is called upon to design a machine to perform some function, the concept of the mechanism that will do the job is arrived at by calling upon one's experience and trying various approaches on paper. Once the design is established and drawings are made, the designer must determine the material of construction for each and every component. The machine designed cannot last long if the materials cannot carry the working loads or if they wear out rapidly. The material selection phase of machine design, like the conceptual phase, is intuitive. There are no equations or computer programs that will select the right material. The design engineer selects the material from the existing drawings because that material has been used in the past and has given satisfactory service. In most of the cases, it may serve the purpose, but the science and technology of materials has changed so much in the last decade that what was the best material some time back may not be the best today. For example, in the earlier days, the weight of the part was the criteria for quality and durability. But in these days of energy crisis, the weight of the component should be minimum to save energy. Therefore, the best material today would be light, strong, and durable. Such a selection of material is possible if the designer has an understanding of the various material systems and their advantages and disadvantages and can call upon this knowledge to make a material selection. A particular material is selected is on the basis of some considerations. First consideration is properties of material. Under properties of material, materials have mechanical properties included strength, ductility, toughness, hardness, strength, to weight ratio, etc. Physical properties, there are density, specific heat, thermal expansion, conductivity, melting point, and many more. Under chemical properties, there are oxidation, corrosion, flammability, toxicity, etc. Under manufacturing properties, there are formed, casting, machined, and welding. Other considerations are cost of material, availability of material and reliability of supply, service in life of material, appearance of material. This is all about the introduction part of mechanical properties of materials. Now let us discuss what are the various types of engineering materials. Engineering materials are classified into two types, metals and non-metals. Metals are classified into two types, ferrous materials that contain iron, non-ferrous materials that contain no iron. Ferrous materials are classified into four types, wrought iron, carbon steels, alloy steels, and cast irons. Non-ferrous materials are classified into six types, aluminum, copper, lead, silver, tin, and zinc. Non-metals are classified into two types, polymers and ceramics. Polymers are classified into two types, thermosetting polymers or plastics and thermoplastic. Thermosetting polymers are classified into three types, aldehyde, polyesters, epoxy resins. Thermoplastic are classified into four types, polyvinyl chloride, that is PVC, polythene, acrylic, and resins. Ceramics are classified into six types, refractories, abrasives, glass, cement, and concrete. These are the basic classification of engineering materials. Now let us discuss one by one. Metals, generally in chemistry, it is defined as an element with a valence of 1, 2 or 3. All metals possess metallic properties such as luster, opacity, malleability, ductility and electrical conductivity. Typical examples of metallic materials are iron, copper, aluminium, zinc, etc. and their alloys. A ceramic can be defined as a combination of one or more metals with a non-metallic element. Hence, metal oxides, carbides, nitrides, borides and silicates are considered as ceramics. They are characterized by high hardness, abrasion resistance, bitterness and chemical inertness and are poor conductors of electricity. Typical examples of ceramics included refractories, glasses, abrasives, clays and cements. Polymers are organic substances and derivatives of carbon and hydrogen. They are also known as plastics. Most plastics are light in weight and are soft as compared to metals. They possess high corrosion resistance and can be molded into various shapes by the application of heat and pressure. Typical examples of polymers are polyesters, phenolics, polyethylene, nylon and rubber. A composite is a combination of two or more materials that has properties different from its constituents. Typical examples of composites are wood, clay, metals, fiberglass, reinforced plastics, cemented carbides, etc. Composites as a class of engineering material provide almost an unlimited potential for higher strength, stiffness and corrosion resistance over the pure material systems of metals, ceramics and polymers. They will probably be the steels of the next century. Let us discuss mechanical properties of materials. The characteristics of material that describe the behavior under the action of external loads are referred as its mechanical properties. The common mechanical properties are strength. The term strength may be defined as the property of metal by virtue of which it can withstand or support an external force or load without rupture. The strength of a metal is the most important property which plays a decisive role in designing various structures and components. Types of strengths. First, tensile strength. The tensile strength is defined as the ability of material to resist a stretching load without fracture, or you can tell that the tensile strength of a metal is the value of load applied to break it off by the pulling in outwards into two pieces. Mathematically, tensile stress will be maximum tensile load by original cross-sectional area. Next, compressive strength. The ability of a material to resist squeezing or compressive load without fracture is called compressive strength. Or you can tell that the compressive strength of a metal is the value of load applied to break it off by crushing. Mathematically, compressive stress is equal to maximum compressive load by original cross-sectional area. Next, shear strength. The ability of a material to resist transverse loads, that is loads tending to separate or cut the material, is called shear strength. Or you can tell that the shear strength of a material is the value of load applied tangentially to shear it off across the resisting section. Mathematically, shear strength will be equal to maximum tangential load by original cross-sectional area. Next, stiffness. What is stiffness? The term stiffness may be defined as a property of a metal by virtue of which it resists deformation. Within the elastic limit, stiffness is measured by the modulus of elasticity. It is the measure of stiffness of a metal. The stiffness of a metal is of great importance while selecting it for a member or a component of a machine or a structure. It is also used in graduating spring balances, and spring control measuring instruments. Other important mechanical properties of metals is elasticity. The term elasticity may be defined as the property of a metal by virtue of which it is able to retain its original shape and size after the removal of the load. In nature, no material is perfectly elastic over the entire range of stress up to rupture. Steel and some other metals have a wide range over which they appear to be elastic. The elasticity is always desirable in metals used in machine tools and other structural members. Another important mechanical properties of metals is plasticity. The term plasticity may be defined as the property of a metal by virtue of which a permanent deformation without fracture takes place whenever it is subjected to the action of external forces. The plasticity of a metal depends upon its nature and the environmental conditions, that is, whether the metal is shaped red hot or in cold. Most of the metals have been found to possess a good plasticity. Lead has good plasticity even at room temperature, which cast iron does not possess any appreciable plasticity even when red hot. This property finds its use in forming, shaping, and extruding operations of metals. Another important mechanical properties of metal is ductility. The term ductility may be defined as the property of metal by virtue of which it can be drawn into thin wires or elongated before rupture takes place. It depends upon the grain size of the metal crystals. The measures of the ductility of a metal are its percentage elongation and percentage reduction in the cross-sectional area before rupture. The term percentage elongation is the maximum increase in the length expressed as percentage of original length. Mathematically, percentage of original length and percentage elongation will be equal to increase in length by original length into 100. The ductile material commonly used in engineering practice are mild steel, copper, aluminium, nickel, zinc, tin, and lead. Another important mechanical properties of metal is malleability. It is a special case of ductility which permits materials to be rolled or hammered into thin sheets. A malleable material should be plastic, but it is not essential to be so strong. The malleable materials commonly used in engineering practice are lead, soft steel, wrought iron, copper, and aluminium. Another important mechanical properties of metal is toughness. It is the property of a material to resist fracture due to high impact loads like hammer blows. The toughness of the material decreases when it is heated. It is measured by the amount of energy that a unit volume of the material has absorbed after being stressed up to the point of fracture. This property is desirable in parts subjected to shock and impact loads. Another important mechanical properties of metals is brittleness. It is the property of a material opposite to ductility. It is the property of breaking of a material with little permanent distortion. Brittle materials, when subjected to tensile loads, snap off without giving any sensible elongation. Cast iron is a brittle material. Next, hardness. Hardness is another important mechanical properties of metals. One of the most simple and useful properties of metal is that of hardness. The term hardness is used to designate several qualities of a metal. Hardness may indicate resistance to abrasion, scratching, cutting, or shaping. It may denote strength, stiffness, brittleness, resilience, toughness, or combination of these properties. Its meaning depending upon the material and on the use to which the material is to be subjected. The hardness of a material usually implies the resistance to deformation or indentation. It is an easily measured quantity. There are three general types of hardness measurements depending upon the matter in which the test is conducted. These are scratch hardness, indentation hardness, and rebound hardness. Let us discuss about scratch hardness. Scratch hardness determines scratching and abrasion ability of a metal when scratched by a standard substance. The standard substances are either minerals or files. Some minerals have been given hardness numbers from 1 to 10 on the Mohs scale. Next, indentation hardness. Another type of hardness which is more commonly used is called indentation hardness. The method gives quantitative values, and materials having even a small change in hardness can be distinguished. The hardness values obtained can be correlated with other properties like tensile strain, wear resistance, etc. Last one, rebound hardness. The rebound hardness is measured using a Shore oscilloscope. This hardness tester is entirely different in principle from other machines such as Brinell, Rockwell and Vickers. This test measures the rebound of a weight that is dropped onto the specimen. Creep is another important mechanical properties of materials. When a part is subjected to a constant stress at high temperature for a long period of time, it will undergo a slow and permanent deformation called creep. This property is considered in designing internal combustion engines, boilers and turbines. Another important mechanical properties of metals is fatigue. When a material is subjected to repeated stresses, it fails at stresses below the yield point stresses. Such type of failure of a material is known as fatigue. The failure is caused by means of a progressive crack formation, which are usually fine and of microscopic size. This property is considered in designing shafts, connecting rods, springs, gears, etc. Resilience is another important mechanical properties of metals. It is the property of a material to absorb energy and to resist shock and impact loads. It is measured by the amount of energy absorbed per unit volume within elastic limit. This property is essential for spring materials. There are another important mechanical properties: machinability, weldability, castability and strain hardening. Let us discuss one by one. Machinability. It is the property of a material which refers to a relative case with which a material can be cut. The machinability of a material can be measured in a number of ways, such as comparing the tool life for cutting different materials or thrust required to remove the material at some given rate, or the energy required to remove a unit volume of the material. It may be noted that brass can be easily machined than steel. Weldability. It is the ability of a material to be joined by welding. Weldability depends on chemical composition, physical properties and heat treatment to which they are subjected. Castability. Castability of metal refers to the ease with which it can be cast into different shapes and is concerned with the behavior of metal in its molten state. The various factors affecting the castability of a metal are solidification rate, gas porosity and shrinkage. Next, strain hardening. The straightening effect produced in metals by plastic deformation, that is cold working, is called strain hardening or work hardening. Strain hardening reduces ductility and corrosion resistance but raises the hardness and electrical resistance. What are the main factors that affecting mechanical properties of metal? Grain size, temperature and heat treatment, and atmospheric exposure. Let us discuss how they affect the mechanical properties of metal. First, grain size. We know that the metals are composed of crystal or grains. If the grain size of a metal is small, it is called a fine grained metal, and if the grain size of a metal is large, it is called a coarse grained metal. It has been observed that a fine grained metal has a greater tensile and fatigue strength, whereas a coarse grained metal has greater hardenability and forgeability. Moreover, it has better creep resistance. It is less tough and has a greater tendency to cause distortion. Next important factor is temperature. The temperature of a metal greatly affects its mechanical properties. It has been observed that with the decrease in temperature, the tensile and yield strength of a metal increases, but the toughness and ductility decreases. In some of the metals such as copper, nickel, aluminum and austenite steel, the toughness and ductility show a gradual decrease in their values with the decrease in temperature. In some other metals such as iron, there is a sudden decrease in these properties. The creep resistance of a metal also increases with the decrease in temperature. On the other hand, increase of temperature decreases tensile and yield strengths, but the toughness and ductility increases. Another important factor that affects mechanical properties of a metal is heat treatment. The heat treatment is an operation or a combination or operations involving heating and cooling of a metal or an alloy in its solid state. It is done in order to obtain certain desirable properties or conditions in a metal. It has been observed that the heat treatment of a metal increases tensile strength, hardness, ductility and shock resistance, etc. It improves the miscibility of a metal. Another important factor that affects the mechanical properties of metal is atmospheric exposure. Sometimes a metal is exposed to a normal atmosphere combining wet air or to an industrial atmosphere for a considerable period. In such a case, a thin oxide film is formed on the surface of the metal. This oxide film breaks down due to crack or discontinuity in it. As a result of this, the condensed moisture on the surface of the metal absorbs carbon dioxide, sulfur dioxide, hydrogen sulfide, etc. from the atmosphere and produces dilute acids. These acids act as electrolyte. This results in the formation of electrochemical cell in which electron current starts flowing from the exposed metal through the electrolyte to the other regions of the metal which is still protected. It has been observed that the atmospheric exposure of a metal decreases the tensile and fatigue strengths of a metal. These are the main important factors that affect the mechanical properties of a metal, that are grain size, temperature, heat treatment and atmospheric exposure. This is all about mechanical properties of metals. If you like this lecture, please like and subscribe my channel. Thank you.